So if you wanted to find out what the domain is for your function, you would just take whatever that is, set it greater than 0, and solve for x, and that is your domain. So here, if we took this example right here, we take our expression x minus 12, set it greater than 0, and solve. Okay? And so here we get x is greater than 12. So that tells us our domain is from 12 all the way to infinity, and that would be the domain. And now notice that that applies directly to the same thing that we would do if we're looking for a shift, right? The transformational shifts. What value of x gives you a 0 in here? 12. So that's where our vertical asymptote is going to be. We'll talk about that in a second. But the domain is everything to the right of that. Right? I want you to try these remaining two problems here. See if you can find what the domain is using this same rule that the input of your log has to be a positive value. So if you just take your expression that's in the input, 5 plus 3x, set it greater than 0, and solve for x. Subtract 5 from both sides, divide by 3. There's your inequality. So when we write it as interval notation, our lower limit, if x is greater than negative 5/3, all the way to infinity, would be our domain. For the second example, same idea, 7 minus 6x. Take that expression, set it greater than 0, and solve for x. You can solve for x one of two ways. If you keep it on the left side, you would subtract 7 from both sides. When you multiply or divide by a negative, you have to switch your inequality symbol. So I would get x is less than 7/6. If that's the case, then I know 7/6 is my highest value, and my inputs would be everything to the left of that. Now I said there were two ways that you could approach this. The other way is you could have just left the 7 where it is, but add 6x to both sides, and then divide both sides. You get 7/6 is greater than x, and that's the same thing. X is less than 7/6 when you rewrite it with the x first. So you can do it either of those ways, whatever makes sense to you.